Assalamu alaikum warahmatullahi wabarakatuh. My name is Muhammad Aslam Zuhairi, and today I will be talking about the use of remote sensing in the management and monitoring of harmful algal blooms. First and foremost, we have to know what are harmful algal blooms or HABs. So, an algal bloom is defined as the rapid growth or accumulation of algae in aquatic environments. Harmful algal blooms, better known as HAB, are algal blooms composed of phytoplankton known to produce biotoxins naturally that are harmful to the environment, to the resident population and humans. This is because the presence of harmful algal blooms may lead to fish to die off and sickness in fish as well as human sickness when these organisms which are affected by harmful algal blooms are consumed. How do you know if harmful algal blooms are occurring near you? So, there are a few methods of identifying harmful algal blooms. Algal blooms or blue-green algae can be identified by their color. So, the color of harmful algal blooms may range from red to a bright neon green or a more of a blue-green. And their texture is like scum or foam in the form of a mat that stays on top of the water. Their smell can be very pungent or a musty smell. One of the main problems of harmful algal blooms is that its diversity in appearance and smell. So, one would have to refer to the local authorities to know if the water body near you are safe to swim or to drink. What causes algal blooms? Algal blooms are caused by excessive amounts of nitrates, phosphates, and other nutrients entering an aquatic environment. This happens often by discharge from sewage treatment plants and septic tanks, or stormwater runoff from fertilized lawns and farms. How do we map or how do we detect harmful algal blooms? Through the use of remote sensing. The first thing that we need to know or to detect is the parameters. There are a few parameters required in the detection and monitoring of harmful algal blooms through the use of remote sensing. First is chlorophyll A concentration. Chlorophyll A exists in most phytoplankton species. The second parameter is sea surface temperature. And lastly is the optical characteristics such as absorption and backscattering of sunlight. Secondly, there are a few satellites or sensors which are used to detect or monitor harmful algal blooms. Some examples are Landsat 7 and Landsat 8, Terra and Aqua satellites, Suomi National Polar Partnership SNPP, and Sentinel-2 as well as Sentinel-3. The existence of these satellites and the advancement in remote sensing as well as GIS technology have made it easier for coastal managers or for local authorities to monitor harmful algal blooms. One would only have to know which buttons to click to be able to monitor the occurrence of harmful algal blooms in their area. So there are a few websites for data access for HAB which are useful for harmful algal blooms monitoring. One may obtain the data for chlorophyll A concentration as well as sea surface temperature (SST) from these websites. First is the Ocean Color Web. Next is the Giovanni, which stands for Geospatial Interactive Online Visualization and Analysis Infrastructure. These two websites are useful for the acquiring of chlorophyll A and SST data for the monitoring of harmful algal blooms. Other than that, a software which one may use for the processing and visualization of harmful algal blooms from these images, from the images obtained from these two websites, which are Ocean Color Web and Giovanni, is CDAS. What is CDAS? CDAS is a comprehensive image analysis package developed for the processing, display, analysis, and quality control of ocean color data. CDAS offers the ability for users to process satellite data from a number of ocean color missions, both US and international, through various processing levels such as level 0 until level 3. Even with the advancement in technology of remote sensing and GIS, there are a few limitations in HAB monitoring using remote sensing. First is that it is difficult for remote sensing images to separate ocean color changes from sediments, dissolved matter, and chlorophyll A, especially when all of these parameters are present. Secondly, it is not possible to characterize algal types or toxins only from remote sensing observations. Thirdly, feasibility of HAB monitoring in coastal and inland water bodies depends on spatial, temporal, and spectral resolutions of remote sensing. Hence, the higher resolution results in a higher accuracy of monitoring and detecting HAB. Other than that, remote sensing reflectance has to be corrected to account for interference from atmospheric constituents such as aerosols. Lastly, it is not possible to observe using optical remote sensing in the presence of clouds.